Okay, so how about this one? What if I broke down every fibre of your being into a pile of individual cells and then rebuilt you cell by cell? Are you still you?
I'm lost.
To help us out with these very complex questions, I'm going to introduce you to a very simple creature. One of the simplest on the planet, in fact, and my new favourite animal, a sea sponge.
They're often described by what they lack. Sponges lack nerves, lack muscles, lack guts. People get confused as to how they actually do things.
This is Sally Lees, spongeologist. Is that your job title? Are you a spongeologist?
Well, I am in certain spheres.
She's a marine biologist, a professor of biological sciences at the University of Alberta, and sponges are her thing.
I mean, it's amazing you can spend your life on this stuff, right? I mean, there must be something else to do. But sponges are aquiferous animals. They live in water systems, so marine and freshwater.
Sponges have been around for a long time, between 5 and 8 million years. They're essentially giant water-filtering tubes. They have no muscles, no organs, no nervous system.
No brain, no thoughts, no feelings. So you'd think no sense of self. But sponges can do this pretty amazing trick.
So if you take a sponge, snip a piece off, put it through mesh of very small size, so 20 microns or so, the ooze that comes out of that is actually cells still. Those cells crawl around and bump into each other and then make connections. If you have enough of the cells, they will eventually organize themselves into forming the entire body again.
Have you seen Terminator 2?
Was I alive in the 90s, you mean? Yes, Emily, I've seen Terminator 2.
Okay, well, remember the scene where the evil Terminator gets frozen in liquid nitrogen and Arnie says, "Hasta la vista, baby," and shoots him and he shatters all over the floor?
Yeah.
Then, just when you think he's a goner, the hundreds of tiny pieces melt and blob together and start to reform back into the Terminator.
Yeah.
Well, that's what we're talking about. Sponges can really do this, re-aggregate themselves from a kind of living sludge on the seafloor.
The classic sort of experiment is to do this with a blue sponge and a red sponge, and then they will actually sort themselves out and become only the blue sponge cells and only the red sponge cells. So they have this ability to determine self from non-self.
They can determine self from non-self.
Yep, sponges have some kind of a sense of self encoded right into the individual cells.
So wait, you push a blue sponge and a red sponge through this mesh.
Yeah.
So you've got this purplish cloud of cells.
Uh-huh.
And this cellular ooze reforms itself into a blue sponge and a red sponge.
In the right conditions and in enough time, yes.
It will take the better part of a week to 10 days before you've really got something that's starting to look like a sponge.
Is the sponge that got disassociated the same sponge that reaggregates? Is it the same animal?
That's a very interesting question, isn't it? Genetically, it is.
This is the million-dollar question, really, isn't it? Philosophically, is that the same sponge? Or is it a new animal, a clone?
It's hard to tell. It kind of depends on how much of the original sponge makes the jump, how much of its memories and personality and other things that we think of as making up the self.
But hold on, we've just established that sponges don't have a brain. They can't have personalities or memories.
Well, that's another amazing thing about sponges. They kind of do.
So you can actually watch them get irritated by things.
How does a sponge get irritated?
It gets irritated by motion. So if you hit the table, they will feel that vibration through the water and it spits out its water. We call it a sneeze. It'll probably take about an hour and then it'll relax again. So you basically have to find something else to do until the sponge is finished doing that. Students will put the sponges ready for doing an experiment the next day because the sponge will get irritated if you do it in the morning, you know. We sort of get to know these animals, their character, by working with them in the labs.
So can they learn things?
There's learning in the neuron sense, which is a different thing here. But the kind of learning I think you're talking about is, can the cells recognize a situation that they've encountered before? And that actually is possible. So for example, many moons ago, what I would do is cut a little piece off of it and...
Sally told me about a time she essentially trained a sponge to cling onto the Petri dish just the way she wanted it to. It would form this ball, she would pry it open again, it would ball up again, but...
By the 5th day, I had no problem. The tissue would adhere and do exactly what I wanted it to do. So in that case, they can learn and they can adapt.
Would those adaptations survive this process?